We now want to learn how to solve quadratic equations, not expressions, by factoring. And we're going to use the zero product rule. And that is that if we have a product of two quantities equal to zero, the conclusion is that one of the factors, either x equals zero or y equals zero. From back in arithmetic days, product of two values equal to zero means one of the factors has to be a zero. So let's look at the given problem. 5x minus 15x squared equals 0. We cannot draw a conclusion about a difference equaling 0, but we can draw a conclusion about a product equaling 0. Notice we have a common factor of 5x, and therefore I'm left with 1 minus 3x. That product is equal to 0. That means either 5x is equal to 0, which means that x equals 0, or 1 minus 3x equals 0, meaning 1 equals 3x, or that x equals 1/3. So there are two solutions to this problem. Let's check. Plug in the solution x equals 0 to the original problem. 5 times 0, take away 15 times 0 squared. Does that result equal 0? Yes. Check the second solution, 1/3. 5 times a third, parentheses 1 minus 3 times a third. Well, inside the parentheses, 3 times a third is 1. 1 take away 1 is 0. And 5/3 times 0 is 0. So both answers are solutions to the original problem. Let's look at this quadratic equation. It's quadratic because the highest power is 2. So we have z squared minus 9z equals negative 14. Knowing something equals negative 14 doesn't help. What we need to do is see if we can get a 0 on one side and a product on the other. So let's bring everything to the left in descending order. Notice when I move minus 14 to the left, it becomes positive 14. We now have a simple trinomial where the lead coefficient is 1. So it's relatively easy to factor or see if it factors. Z and Z. Factors of 14 might be 14 and 1. That's not going to work. Or 2 and 7. And I think that will work. We want an inside product is negative 9. So this is a negative 2z. This would be a negative 7z. The total would be negative 9z. And the product of the last terms would be plus 14. We can draw a conclusion that either z minus 2 equals 0, meaning z equals 2, or z minus 7 equals 0, meaning z equals 7. Two possible solutions to the original problem. Let's look at the next problem, which is 5x squared plus 16x is equal to 4x squared minus 64. It's a quadratic equation because of the power 2. Let's bring all terms to one side. So we have 5x squared minus 4x squared plus 16x plus 64 equals 0. Simplifying, we have x squared plus 16x plus 64 equals 0. We have a trinomial whose lead coefficient is 1, easy type, but I'm looking and seeing that the first term and last term are positive in squares, so I'm going to play a hunch that this is a trinomial square. Take the square root of the first term, which is x, the square root of the last term, which is 8, form the product of 8 and x, which is 8x, double it, which is 16x. So it is a trinomial square. Put the plus sign down. And that result, that product is equal to 0. We do not have two distinct factors. We have one factor repeated, x plus 8 equals 0. We can solve and x equals minus 8. In a higher level of math, this will become a double root that means something in terms of graphing the problem. But right now, there's only one solution to this problem, x equals minus 8. And for our last problem, let's try 4t times t minus 1 equals 24. We do have a product, but it's equal to 24. No conclusions can be drawn. So we're going to have to undo the product, which is 4t squared, this is distribution, minus 4t equals 24. Bring all terms to the left. That's 4t squared minus 4t minus 24 equals 0. And because this is an equation, and I've seen there's a common factor in each term, we can divide out the common factor. You cannot divide out a variable term, but you can divide out a common factor. So dividing everything by 4, this becomes t squared minus 1t minus 6 equals 0. It's a simple trinomial. Lie coefficient is 1. Let's see if it factors. T and t. 6 could be 3 and 2. We want a middle term that's negative 1t, make the 3 negative and the 2 positive. We do get the last term when we multiply. Since we have factored completely, we can set each factor to 0. That means t minus 3 could be 0, implying that t equals 3. The other possibility, get my picture out of the way, is that t plus 2 equals 0, t equals minus 2. So there are two solutions to this problem.